In this video, we're going to take a look at similar triangles. So first thing you have to note is that similar triangles are two triangles. One is a scaled up version of the other. So here's an example. I've drawn a triangle. I'll make a copy of it and I'm going to then make it bigger. Right? What's preserved and what's the same as before is the angles. So that angle is still going to be the same as that angle. This angle in here is still going to be the same as that angle, and the same with the top one up here. That's going to be the same as well. So these two are similar triangles. How you prove they're similar is you look to show that all of the corresponding angles, when they're orientated or arranged in the same way, that all of those have the same measure, that those are congruent. So that's a key word that you need to be aware of. Congruent means that they are geometrically identical. So for similar triangles, we want to prove that corresponding angles are congruent, geometrically identical. So for this, they say explain why the triangles ABE and ACD are similar. The first thing I would be doing there is drawing out the two triangles. So ABE is that top one there. So I'm going to draw a rough sketch of it. So we've got ABE. This is 112. And I'm going to mark this angle in at the top. And you'll see why in a second. It'll become very clear why we need that. There's A, there's B, and there is E. The next thing I'm going to do is I'm going to draw out ACD. So that's if I went the whole way down. So it's a little bit bigger. So we've got A at the top there. We'll have C down here, and then we'll have D. As best you can. It's not very accurate, but it's going to help me. It's a model. It doesn't have to be perfect. What you'll note is that that angle up there for A, that's exactly the same here as well. So I have one angle that's definitely the same. If we look at the next one, my 112, that's exactly the same and in the same position. And here's the other thing. If two of the angles are the same, no matter what this value is here, the third one also has to be the same. And the reason for that is in both triangles, all of the angles add up to 180. You know that from primary school. So if I know that all three angles are the same, I know that they are similar. Now I have to show that and write that down as a proof. So there's no formal proofs that you have to remember for Junior Cert anymore, but you have to be able to present a logical argument. So what I'm going to say is I'm going to say the angle here, BAE, so the measure of the angle BAE is equal to, even more so, I'm going to say it's congruent to the angle CAD. So it's congruent to the angle CAD. Then I also know these two are congruent. They're exactly the same. So the measure of the angle EBA, so make sure you know how to label your angles, is congruent to the angle DCA. So angle DCA. The last one then, we also know that this angle down here is the same. So we're going to have that angle AEB, that's the same as angle ADC. And then, since you've got three angles that are congruent, you have met the condition for similarity. So once you've proven the three corresponding angles are the same, corresponding means that they're in the same orientation. So they're both facing upright. A is at the top. I've proven all of the angles that are in the same positions are equal, therefore they are similar. So we just conclude, therefore, the triangles ABE and triangle ADC are similar. Okay, so they are similar. So very important, you know the difference between similar triangles and congruent triangles. Similar is one is a scaled version of the other. Okay, congruent means they're completely identical, all of the sides are the same. Now, here's the next thing. Once I have proven that they are similar, I can now use this along with the scaling factor to figure out all of the sides. So it says find the lengths of A to D. So what I knew before is that A to E is 7 and they want me to find this side here. I don't know what it is. Let me call it X for a moment. So what I do know, however, is that there is some sort of scale here where 2 at the bottom gets turned into a 5. Now, there's lots of different ways that you can do this. I actually like to do it by finding the scaling factor first and then applying it where I need to. So 2 gets turned into 5. How does that happen? So I'm going to have to divide it by 2. To get it back to 1 and then multiply it by 5. So I'm going to say 2 times, if I divide it by 2 and multiply it by 5, I get my 5 in the end. Now, how's another way I could do that? You can take the bigger number and divide it by the smaller number for the scale factor. So if you just want a quick way of working it out, you can take the bigger number, which is the 5, divided by the smaller number. So that's my scale factor, 5 over 2 or 2.5. So that scale factor is the same that's applied throughout the whole triangle. So I'm going to take 7 and I'm going to change it into this total value here, x, by multiplying it by 2.5. So I'm going to say 7 multiplied by my scale factor, which is 2.5, that will give me x at the end there. So I'm going to do 7 by my 2.5 and my new side works out to be 17.5. So the total length now is 17.5. And they've given it in centimeters, so it would be good practice for us to always make sure we have those units as well. So 17.5. The next one then is to calculate E to D or D to E. Well, we just figured out that the total length here is 17.5 from A to D. So if I wanted to figure out just what this little section was, how would I do that? Well, I know the total is 17.5. And I know this section is 7, so what's left over is 10.5 for this one. But just to show our workings in the exam, so that was, say, part 1, and I'm doing part 2 here now. So that was A, and this is part 2. So we have 17.5, take away 7 leaves us with 10.5. So the length of D to E is 10.5. The next part then is to find out B to C. So we do the same thing. They're actually asking us the exact same question, but they're just not breaking it up into the steps for us. So we know that this is 6. Let's find first A to C using our scaling factor, and then let's take away the 6. So let's do that. So I'm going to have that I start out with 6 in the smaller triangle. It's going to be scaled up by a factor of 2.5. So I'm going to do 6 multiplied by 2.5, which gives me 15. If I know that the whole thing is 15, how will I find the smaller section? Well, that's 6. And if the whole thing is 15, I'm going to get B to C. It will be 15 take away 6, which gives us 9. So that's the big idea around similar triangles. It's when you have two triangles that are basically, one is a scaled up version of the other. You have to find the scaling factor. How you can do that, you can do it by talking yourself through what do I have to do to turn 2 into 5, or if you didn't like that, you could simply put the bigger number over the smaller number, and then that's going to be your scaling factor. Okay, it'll work it out for you that way as well. Now, the next question I have here is very similar, only they don't kind of hold our hand as much. And this would be in line with the kind of exam paper questions. So they don't even tell us that they are similar first. So we might need to just confirm that. So I'm going to draw out the two triangles first. So they're in the same orientation to begin with. We would actually call these nested triangles because it's one inside of another. So the bigger triangle here is AEC, and then nested inside of it, we have B, D, and C. Okay, so there's B, there's D, and there's C. Now, again, look for ones that are just outright the exact same angle. So that angle C there is the same as that one there. We're also told with these lines here, that tells us that they are parallel. Now you need to call on your theorems from first year. Parallel lines with a transversal passing through it. This is a transversal passing through them. So this angle in here will be the exact same as that angle in there, because they are parallel. So that angle there is at E, that angle there is at D. Now, you can also use the parallel lines here and call this your transversal. You'll get that that third one's going to be the same as well. The other way you could have kind of rationalized that for yourself is if two of the angles in the triangle are the same, the third by default will also be the same. So that's also going to match. So I have now definitely confirmed for myself that they are similar triangles, and I can investigate and use the scaling factor. Now, what I need to look at is I need to work out the length of A to B. So I know what B to C is. So if I could figure out A to C, so the length of A to C, take away the length of B to C, sure wouldn't that give me AB? The length of A to B. So what I'm going to do now is I'm going to say, I need to find out really, the one I don't know is A to C. So A to C, let me call that X. B to C is going to be 15. I know the full distance E to C is 21. I know B to D is 9, and I know this is 10.5. Now, what I need to figure out then is the scaling factor, and I'm going to use two sides that are known and match in both of the triangles. So this side right here matches this side right here, right? It's between the green and the red angle, both of them. And what I know is that 9 gets scaled up to 10.5. So for my scale factor, I'm going to figure it out by doing 10.5 divided by 9. So if I do that, I'm going to have 10.5 divided by 9. When I do that, it's not so nice. It is 7 over 6. So I'm just going to keep it as 7 over 6 for a minute. So 7 over 6 is my scale factor. So if I want to turn 9 into that, I'm going to multiply it by 7 over 6. So you can test it out. 9 by 7 over 6, it does give us 10.5. So that also means that 15 multiplied by 7 over 6, that will give us X. So let's do that then. We're going to scale up our 15. X is going to be equal to 15 multiplied by our scale factor, which is 7 over 6. So 15 times 7 over 6 gives me 17.5. So there's what the value of x is. Now always reflect on am I finished? So that is our scale factor of 17.5 when we scale it up. Now I need to think about, did I finish it? So we said A to C, which we've now got, which is 17.5. Take away B to C, which is 15. That will leave me with the length of A to B, which is 2.5. So I've worked that out. Now, that one was almost identical to the last one. I just want to show you what if they asked us. They didn't, but what if they did? As higher level students, they could ask us to find D to C. Now, how is that going to work? Well, we're going to take 21 and we're going to scale it down. So when you scale it down, you divide. So if I want to go from E to C to work out the length of D to C, I'm going to take 21. So to work out from E to C, divided by the scale factor, is going to give us D to C. So E to C was equal to 21 divided by my scale factor, which is 7/6. So just take your time putting it into the calculator. I'm going to have 21 divided by 7/6, and I get a value of, let's see, so I'm going to have 21 divided by 7/6, I get 18. So 18 centimeters or whatever, centimeters it's going to be. So if you're making it bigger, you're going to multiply. If you're making it smaller, you're going to divide. Make sure you know how to identify similar triangles. You need to know all of your theorems from first year around parallel lines and intersecting lines. So when it has vertically opposite angles, when they have corresponding angles, when they have alternate angles, you need to be aware of all of those first, because that's going to help you to prove that they're similar. Once you have proven that they are similar, then you look for the scale factor. You use two sides that you know, one from the big triangle, one from the small triangle. Easiest way to get your scale factor is take the big divided by the small. That will tell you what it's blown up by. Then if you want to go from the small triangle into the big one, you're going to multiply. If you have the smaller side if you have the bigger side and you want the smaller side, you're going to divide. So that's similar triangles in a nutshell. The other thing that's good to revise with this then would be congruent triangles, which you would have looked at previously. Make sure you know how to prove that two triangles are congruent also. The difference being, congruent triangles are perfectly identical. They are the same side lengths and the same angles. When you look at similar triangles, you just want to show that when you arrange the triangles in the same way, all of the angles that are matching have the same value.